Okay, this is the second video for 4.4. So we're starting actually on example number 4 that you guys were supposed to have worked. Turned off the video, work, and then you're going to come back and see if you got it right or not. So let me run through this pretty quickly. We're starting, of course, with the prime factorizations, which is 5 times 4, 2 squared times 5, box it up. That's the first one. 45, I'm going to do 9 times 5, which is 3 squared times 5. And 50, I'll do 5 times 10, which is 5 times 5 times 2. So that's 2 times 5 squared. So again, we want to really make sure we've got these prime factorizations right, because if these are wrong, you can see now how your LCM and your GCF are going to be wrong also. So we're going to make our T-chart. I'm going to start with the GCF. I usually start with the GCF, the smaller guy. I'm looking for bases in common. To be in the GCF, they've got to be in every single prime factorization. So I have a 2 here, but no 2 here. I stop. I can't use 2. I have a 5 here, a 5 here, and a 5 here. That's good. My GCF is 5, and I'm going to put the lowest exponent on it. 5 to the first, I can stop, because there's nothing lower than 5 to the first. The GCF is 5. LCM, every single base I see. So I see a 2 in this first prime factorization, and I also see a 5. I go to the second box. I see a 3. Don't have him written down yet. Here comes the 3. I see a 5. I've already got the 5 written down. I'm not going to write him down twice. I move to the third box. I see a 2. I've already got a 2. I see a 5. I've already got a 5. Now I've got to go back and put the highest exponents that I see in any of these 3 boxes on my bases. So I have a 2 squared and a 2 to the first. 2 squared is the highest base. I have a 5 to the first, 5 to the first, and a 5 to the second. I'm going to use the highest exponent. And then 3, the only 3 I have in here, has an exponent of 2. So now I'm going to clean this up. 2 squared is 4. 5 squared is 25. 3 squared is 9. That's 100 times 9, and the LCM is 900. Look at the difference between the GCF and the LCM. Wazza, wazza. Great big. All right, let's keep going. We're going to do some monomials now. Move that guy over there. So we're going to start just exactly like we did before. This one's simple because the prime factorization of both of these guys is 3. 3s and 3s squared. Don't forget the variables. You'll get it wrong every time if you forget to bring down the variables. GCF. GCF, what do they have in common? Well, they have a 3 in common, and they also have an s in common. I'm going to use the lowest exponent. Well, the lowest exponent on 3 is 3 to the first. The lowest exponent on s is s to the first. So the GCF is 3s. The LCM, same bases. There's no other base to write down. But I'm now going to use the highest exponent. And the only thing that changes is instead of putting the first s to the 1 on the GCF, on the LCM, we're going to say x squared. These go kind of quick because there's no number, so the prime factorization is the monomial. Much simpler than when you have to deal with numbers. GCF, what do they have in common? X, what's the lowest exponent? 2. LCM, all the bases you see, I only see one base, x. Highest exponent, however, x to the 4th. All right, a couple more now. We're throwing some numbers out here. These are still pretty small numbers. This should go pretty quick. 3 squared m is the prime factorization, and 3 times 5 m squared is the prime factorization for the second term, the second monomial. GCF, LCM. Okay, GCF. What do I see in common? I see a base of 3, and I see a base of m. The lowest exponent I see on 3 is this guy over here, 3 to the first. And m, right here, m to the first. I'm done. 3m is the GCF. LCM is different. I'm going to write down every numeric base I see. I see a 3 and I see a 5. Even though this 5 isn't in this one, for the LCM it doesn't matter. And then of course I see the variable m in both of them. I'm going to go back, put the exponents. The highest exponent I see on 3 is to the power of 2. 5 is to the first power, and m, the highest exponent of m, is that 2 right there. So I need to clean this up. 9 times 5 is 45m squared is the LCM. All right, I want you to try number 8 on your own. I'm going to pop down to number 9, and then I'm probably going to have you do 10 on your own. So let's look at 9. 12 is 3 times 4 GH, which is 2 squared times 3 GH, and it's in a box. 18, 9 times 2, 6 times 3, doesn't really matter, G squared H. So this is 2 times 3 times 3, G squared H, or 2 times 3 squared, G squared H, all boxed up. And now I'm finally ready to start writing my T-chart. GCF, LCM. GCF has to be in common. So I see a 2 in common, I see a 3 in common, a G in common, and an H in common. They have all the bases in common. The exponent that I need to write down is the smallest that I see. I see a 2 to the first here, so that's got to be the exponent on the 2. I see the 3 to the first here, that's got to be the exponent on the 3. And the G is also to the first power, and the H is as well. Clean it up, 6GH for the GCF. LCM, I write down the same 4 bases because there's no extra bases hanging out, but the exponents are going to be different. 2 is going to be squared, 3 is going to be squared, G is going to be squared, and H is still to the first power. 4 times 9, G squared H, 36 G squared H. Okay? All right, I want you guys to try 10. I think I'm going to stop this video and make a couple more just shorter ones to end up these set of notes. That way you can break these videos up. But do check the on-campus website and make sure that you've gotten through all the videos for this 4.4 section. Bye.